So we are recording at this time. If you speak, you're going to be recorded, just so you know. Okay. So in section 10.2, we are going to be looking at sort of basic trigonometry. And specifically, we're going to be looking at what are called the trig ratios. Specifically, we're going to be looking at sine, cosine, tangent, okay, which maybe you've heard of before, maybe you haven't, just depends on your particular math experience, okay? So we're going to start by talking about how right triangles are generally labeled, okay? So the first skill needed for trigonometry is the ability to label the three sides of a right triangle according to convention: the hypotenuse, the side adjacent to the given acute angle, and the side opposite that angle. In triangle ABC shown below, so here's triangle ABC, okay? The side labeled C is the hypotenuse. So in this triangle, C is the hypotenuse. It's the one opposite of the 90-degree angle. Is that okay? It is the longest side and it's opposite of the right angle. For the acute angle A, so we're going to focus on A right here, okay? We would say that side B is adjacent to angle A. Does that make sense? So it's adjacent to angle A, whereas side A is opposite of angle A. Does that make sense? So whether I have them labeled A, B, and C or what have you, if I'm looking at angle A right here, this side over here is the opposite, and this side right here is the adjacent, and of course that's the hypotenuse. Does that make sense? Okay. So the side opposite that angle is the right angle. What? I messed up there. So, oh, here it is. For acute angle A, B is the adjacent side and A is the opposite side. If we're looking at acute angle B, A is the adjacent side and B is the opposite side. So if we're looking at angle B here, then B over here is opposite of angle B and side A is adjacent. Okay, the hypotenuse will never be the opposite or the adjacent. Okay, does that make sense? It will either be, well, it's the hypotenuse, okay, in a right triangle. So the other two legs will be the opposite and the adjacent, and it just depends. I don't know, I've been doing this a long, long time. And for me, it's always simplest to figure out the opposite first. Okay, so I think about the opposite and then the other one's got to be the adjacent. Okay, but it doesn't really matter. Okay, so far so good. So the terms adjacent side, opposite side, and hypotenuse are used only with right triangles. So if we don't have right triangles, we don't worry about that term, those terms. Does that make sense? Okay. Now in this class, we're only going to worry about right triangles. We're not going to worry about the other ones. So you don't have to worry about that too much. Also, the hypotenuse is never considered to be either the adjacent side or the opposite side. It's not a leg of the triangle. Okay, so identify the hypotenuse first, and you can rule it out for being the adjacent or the opposite. Okay, now the sine ratio. The key to understanding trigonometry is to realize that in every right triangle, there is a fixed relationship connecting the size of either the acute angles to the lengths of the adjacent side. It's an opposite side and the hypotenuse. Say what? Okay. So again, there's a fixed relationship that connects the size of the acute angles with the side opposite, the side adjacent, or the hypotenuse. Okay. So like, for example, if I look at these four different triangles right here, okay, all of these have 20-degree angles for this angle right here, 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 here. Does that make sense? Okay. Well, if that's the case, and if it's a right triangle, then if this is 20 degrees, the other angle up here has to be 70 degrees. So all of those right triangles are similar. Okay, does that make sense? So if they're similar, that means they're proportional. Okay, you follow me on that? Remember when we did proportions? Okay, so for example, in all the right triangles that contain the 20-degree angle, okay, the ratio opposite side over hypotenuse will always have the same value. Okay, so like for example, if the side opposite is A, and if the side adjacent is B, and if the hypotenuse is C, okay, then again, if I compare the opposite side over the hypotenuse, that would be the A over the C. So A over C is going to equal this, whatever A1 is over whatever C1 is, or A2 over C2, or A3 over C3, or A4 over C4. If all of those triangles are similar, then the opposite over hypotenuse ratio will be the same for all of those triangles. Does that make sense? Okay. Now, again, that's only going to be true if it's like a 20-degree angle and if it's a right triangle. Okay. Does that make sense? If it's not a right triangle, then they wouldn't necessarily have to be similar. Okay. Makes sense? You could have a 20-degree angle, like that could be a 20-degree angle, but that's not similar to these because it's not a right triangle. Does that make sense? Okay. Okay. So anyway, for all of these triangles, the opposite over the hypotenuse is going to be the same thing because the angle is the same. Okay. This ratio is approximately 0.342. So if I knew what if I took out my ruler and measured this side and I measured the hypotenuse, and if I divided the opposite by the hypotenuse, I would get about 0.342 on all four of these triangles. Okay. And I would for any other right triangle that has a 20-degree angle as the acute angle here. Does that make sense? That's the key to trig. Knowing those ratios is the key to trigonometry. Okay. So this kind of ratio of the side lengths of a right triangle is called a trigonometric ratio. Altogether, there are 6 such ratios, but we will only study 3 of them. Okay. For the triangle ABC shown, the sine ratio, which is going to be abbreviated SIN, so SIN stands for sine, is defined as follows. Okay. So if I have this right triangle right here, okay, so I've got angle A, I've got angle B. So for angle A, side A is the opposite, C is the hypotenuse, B is the adjacent. Okay. So the sine of angle A is going to equal the side opposite of angle A, which is the A, over the hypotenuse, which is C. Okay. Does that make sense? Same triangle, but if I look at angle B, the sine of angle B, which will be the side opposite of angle B, which is B, over the hypotenuse, which is C. Does that make sense? Okay. So we've defined the sine of angle A, we've defined the sine of angle B. We're not going to do the sine of angle C because that's the 90-degree angle. Okay, so we're only going to do this for the adjacent angles. It is possible to do it for I said the wrong thing. We're only going to do it for the acute angles. Okay, I said adjacent, but we're only going to do it for the acute angles. Now, it is possible to do it for like the 90-degree angle and so on, but we're not going to worry about that in this class. Okay, so far so good. So the notation sine A is read the sine of angle A, and the notation sin B is read the sine of angle B. Okay, and again, it means the sine of angle A means the side opposite of angle A over the hypotenuse. The sine of angle B means the side opposite of angle B over the hypotenuse. Okay. So example 1, using the triangle shown here to the right, find the approximate value of each of the following, round to 3 decimal places. Okay. So I have this right triangle. And so the hypotenuse is 90.0. This side here is 72.8. This side here is 52.9. And we're told that this angle right here is 36 degrees. Okay. So that's like my angle A. Okay. So we want to find the sine of 36 degrees using this triangle. Okay. Does that make sense? So for this angle, 36 degrees, the sine is going to be the opposite, which would be 52.9 over the hypotenuse, which would be 90. So the sine of 36 degrees is 52.9 divided by 90.0. And we're supposed to round that to 3 decimal places. So I'm going to actually do the calculation. So 52.9 divided by 90.0 is about 0.588 if I round to 3 places. Is that okay? So that's my answer, 0.588. Okay. Isn't that hard? Now for part B, we're supposed to find the sine of 54 degrees. Well, how am I going to do that? Well, if this is 90 degrees and this is 36 degrees, remember they have to add up to be 180. So in other words, 36 and this angle has to add up to be 90 because this is 90 already. And so 36 plus 54 is 90. So that angle right there has to be 54 degrees. Make sense? So the sine of 54 degrees is going to be the side opposite of the 54 degree angle over the hypotenuse. So opposite of the 54 degree angle is the 72.8. So 72.8 over the hypotenuse 90.0. And so that is about 0.809. If I round to 3 places as I'm directed. Any questions about that? So again, the sine of an angle is the opposite over the hypotenuse. Okay. Every possible angle X will have some number that we'll call the sine of X associated with it. If X is an acute angle, we can calculate the value of sine of X from any right triangle that contains X. Okay. So again, if X is like an angle, right? We can, from any 90 degree, any right triangle that has an X angle in it, we could use that to calculate the sine of X. Okay, make sense? Okay. Cosine. The cosine ratio works just like the sine ratio, except it's defined as the side adjacent over the hypotenuse. Okay. So a second useful trigonometric ratio is the cosine ratio, abbreviated COS. This ratio is defined as follows. So again, I've got my right triangle with angles A, B, and C. C is the right angle, and side A and side B, and the hypotenuse is side C. Okay. And again, this is pretty common convention. I think we talked about this back when we did the geometry chapter. It's pretty common when you have 3 angles. And if we call the angles usually by capital letters like A, B, C, then the side opposite, we usually use the lowercase for that side length. So if it's angle A, opposite is lowercase a. If it's angle B, then the opposite is lowercase b. If it's angle C, then the opposite is side C. Okay, that makes sense. If I had DEF, then I would use sides DEF using lower cases. Okay. Anyway, so back to the cosine. So the cosine of angle A, so angle A is right here. So it's going to be the side adjacent to angle A, which would be side B, over the hypotenuse, which is C. Does that make sense? And the cosine of angle B, so angle B is right here, so it's going to be the side adjacent to angle B, which is side A, over the hypotenuse, which is C. So it's just like it's just like sine, except sine is opposite over hypotenuse, cosine is adjacent over hypotenuse. Okay, but the ratios, like if I drew this picture back in here, okay, if I have this 20-degree angle, the cosine would be B1 over C1, B2 over C2, B3 over C3, B4 over C4, and all of those will be the same thing because the triangles are similar. Okay. Make sense? So note the notation COSA is read the cosine of angle A, and COSB is read the cosine of angle B. So this example's just like what we did just 2 minutes ago with example 1, except we're going to do cosine. Okay. So using the triangle shown to the right, find the approximate value of each of the following, round to 3 decimal places. So I have the same right triangle here that we had before. Okay. So this is 36 degrees. This is 54 degrees. Okay. So if I want to find the cosine of 36 degrees, well, that's going to be the side adjacent to 36 degrees, which is 72.8 over the hypotenuse, which is 90.0. So that's going to equal 72.8 over 90.0. So 72.8 divided by 90.0 is 0.809. You okay with that? Cosine of 54 degrees. So here's my 54-degree angle. So that's going to be the side adjacent, which is 52.9 over the hypotenuse. So 52.9 over 90.0. And 52.9 divided by 90.0 is 0.588. Isn't that hard? I do want to point out something. We have defined the sine and the cosine. Now, you don't really have to remember this, but if you look, when I found the sine of 36, it was 52.9 over 90 or 0.588. When I found the cosine of 54, it was the same thing. With me? When I found the sine of 54 degrees, it was 0.809. When I found the cosine of 36 degrees, it was the same thing. You with me? That always will work that way as long as we have acute angles. Okay, if we jump outside of acute angles, it doesn't necessarily work that way. But with acute angles, that always works that way. That's why they're called co-functions, sine and cosine. You with me? They're co-functions. They're related. Okay. And so the like 36-degree angle and 54-degree angle, those are called co-angles because they add up to 90 degrees. Okay. Does that make sense? We call them, technically in trigonometry, they're called complementary angles. They add up to 90 degrees. Okay. So they're co-angles. Okay. And so again, the sine of 36 is going to equal the cosine of its complement, okay? And the sine of 54 is going to equal the cosine of its complement. Does that make sense? Okay. That's not really covered here in the lesson. That's just free. Okay. Note, the value of sine of A or cosine of A can never be greater than 1 because the legs of any right triangle can never be longer than the hypotenuse. So if you think about that, the hypotenuse is always going to be longer. So if I do like the opposite over the hypotenuse, the opposite's always got to be a smaller number than the hypotenuse. So the answer is always going to be less than 1. And likewise, if I do the adjacent over the hypotenuse, again, the adjacent is going to be smaller than the hypotenuse. So when you do that division, it's going to be smaller than 1. Okay, does that make sense? Okay. The tangent ratio. A third trigonometric ratio is the tangent ratio, which is abbreviated TAN for tangent. It is defined as follows. The tangent will be the opposite over the adjacent. So we don't use the hypotenuse with the tangent, okay? So for example, here's my right triangle, okay? Angles ABC, so sides ABC, okay? So the tangent of angle A is going to be the side opposite of angle A, which is A, over the side adjacent to angle A, which is B. So A over B are opposite over adjacent. Does that make sense? The tangent of angle B will be the side opposite angle B, which will be B, over the side adjacent to angle B, which is A. Sense? Opposite over adjacent. That is the tangent function. And if I pull this back in, so like if I have a 20-degree angle, the opposite over the adjacent would be A1 over B1. So because all of these are similar, the ratio of A1 over B1 is the same as A2 over B2, which is the same as A3 over B3 and A4 over B4. So it's always going to be the same ratio. Okay, if for this angle that's the same, if it's a right triangle. Okay. So example 3, using the triangle shown to the right, find the approximate value of each of the following. Round to 3 decimal places. So the same right triangle, 36-degree angle down here. So that means we got a 54-degree angle up here. And I'm asking you, what is the tangent of 36 degrees and what is the tangent of 54 degrees? So for the tangent of 36 degrees, the side opposite is 52.9. The side adjacent is 72.8. So the tangent of 36 degrees is 52.9 over 72.8. And if I do that calculation, 52.9 divided by 72.8, that is 0.727 if I round to 3 places. Make sense? The tangent of 54 degrees, well, 54 degrees is here. So the side opposite is the 72.8 and the side adjacent is 52.9. So it's going to equal 72.8 over 52.9. And if I take 72.8 divided by 52.9, that is 1.376. You with me? Now back here, just a minute ago, I said that the sine of A and the cosine of B could never be bigger than 1 because the leg can never be longer than the hypotenuse. That's not the case with tangent, okay? It depends on which leg's longer. You with me? So like if the opposite is shorter than the adjacent, then the ratio is going to be less than 1. But if the opposite is bigger than the adjacent, then the ratio is going to be bigger than 1. Does that make sense? So my note here, unlike the sine and cosine ratios, the tangent ratio can be greater than 1 because it's possible that the opposite leg could be longer than the adjacent leg. Okay. It's also possible it could equal 1. That would happen if we had a 45, 90-degree angle, like we talked about in section 1 last time. Okay. So if we had well, my picture is not the best in the world, but say if this was 45-degree angle and this is 45-degree angle, then whatever this is would be the same as whatever that is because it's an isosceles triangle. Does that make sense? So 45 degrees, the tangent would be whatever this is over whatever this is, and it's going to be 1 because they're the same length. Does that make sense? That would be the only time that happens is when you have a 45-degree angle, because if it's a right triangle, the only way it can be isosceles is if you have 45-degree angles for the other two angles. Does that make sense? Okay. So special right triangles, remember we talked about these, right? So recall the special 45-degree, 45-degree, 90-degree, the 30-degree, 60-degree, 90-degree, and the 3, 4, 5 triangles, okay? So find each of the following, okay? So if I ask you to find the sine of 45 degrees, well, if I use my special triangle, remember the ratio is like 1, 1 and the square root of 2 for the hypotenuse. So 45 degrees here, if I'm doing the sine, that is the opposite over the hypotenuse. So that would be 1 over the square root of 2. Is that okay? And if I take, I didn't really say to round or anything, but let's round to 3 places. Okay. So if I take 1 divided by the square root of 2, that is 0.707. The sine of any 45-degree angle will always be about 0.707. Okay. The cosine of 30 degrees. Well, here's my 30, 60, 90 triangle. So remember the ratios. Like if the short side's 1 and then the hypotenuse is double that, and the other leg is the square root of 3 times that. Okay. So for the 30-degree angle, again, we're doing cosine. So the square root of 3 is the adjacent and 2 is the hypotenuse. So that would be the square root of 3 over 2. So if I do the square root of 3 divided by 2, make sure you get the 2 out from underneath the square root, okay? And that is about 0.866. Make sense? The tangent of 60 degrees. Well, so I picture my 30, 60, 90 triangle. And again, it's going to be 1, 2, square root of 3. Okay. So for tangent of 60 degrees, tangent, remember, is opposite over adjacent. So that's going to be square root of 3 is the opposite over 1's the adjacent. So that's going to be square root of 3 over 1, which incidentally would just be the square root of 3. And the square root of 3 is 1.732. Piece of cake. The sine of 53 degrees. Well, the 53-degree angle comes from the 3, 4, 5 triangle. Okay. So for 53 degrees, and again, we're doing sine. So that's going to be opposite over hypotenuse. So that's going to be 4 over 5. And if we do 4 divided by 5, that's 0.8. So the sine of 53 degrees is 0.8. Now I should tell you, with the 3, 4, 5, the angle is not perfectly 53 degrees. Okay, it's approximately 53 degrees. Does that make sense? And it's approximately 37 degrees. So if we wanted to be more precise, we could. Okay, I'll show you how to do that in a minute. Okay, the tangent of 45 degrees. Well, I actually already talked about this just a little bit. Okay, so looking at my 45, 45, 90 triangle. So if I look at this 45-degree angle, tangent's opposite over adjacent. So that's going to be 1 over 1, which is 1. The cosine of 37 degrees. So I'm looking at my 3, 4, 5 triangle, which has the 37-degree angle approximately here. Now we're doing cosine. So the adjacent is 4, the hypotenuse is 5. So 4 over 5 or 0.8. Notice again what I told you before. Sine of 53 was 0.8. Cosine of 37 is the same thing because 53 and 37 are co-functions, right? They're complements, okay? The sine of 60 degrees, well, 60 degrees is here. So the sine is the opposite over the hypotenuse. So the square root of 3 is the side opposite. 2 is the hypotenuse. So if I do the square root of 3 divided by 2, whoops, that is 0.866. And again, notice that's the same thing we got up here for the cosine of 30. So 30 and 60 are complements. So the cosine of 30 and the sine of 60 equals the same thing. Okay. And last but not least, cosine of 60. Well, 60 is here. So the side adjacent is 1. The hypotenuse is 2. So 1 over 2 or 0.5. If you were to take a trigonometry class, in trigonometry class, we use those all the time, okay? Those special triangles we use all the time. Any questions so far? Note the acronym SOHCAHTOA can be a useful tool to remember the ratios for sine, cosine, tangent, okay? So this is pretty common. I can remember learning this when I was, young. SOHCAHTOA. So stands for sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse. TOA, tangent, opposite over adjacent. So if you have trouble remembering, which one's opposite over hypotenuse, which one's adjacent over hypotenuse, SOHCAHTOA can help you remember that, okay? And so again, that's what I've said here. In the acronym, SO stands for sine, opposite over hypotenuse. CA stands for cosine, adjacent over hypotenuse. TOA stands for tangent, opposite over adjacent. Okay. You ever heard of that before? Yeah. If you ever took any trig whatsoever, then, or if it was like in some other class, if you didn't take a trigonometry class, but could have been covered in some other class, again, that's pretty common acronym that's used. It's kind of like PEMDAS, right? Please excuse my dear Aunt Sally or whatever, to remember the order of operations, okay? Now, sidebar just for a second before I get to the end of this, because we're on our last page. Back here, it said, well, somewhere it said that there are 6 trigonometric ratios. Altogether, there are 6 trigonometric ratios, but we've only looked at 3, the sine, the cosine, and the tangent, okay? Well, the other 3, and you don't have to remember this, this is just free information. The other 3 is called the secant, the cosecant, and the cotangent. Okay, so if you have your right angle here, so like if this is A this is B, this is C, so this is side A, side B, side C, okay? If I do the secant of A, for example, well, first of all, that's abbreviated SEC. So this would be the secant of A. And the secant of A is like cosine is adjacent over hypotenuse. Well, secant is hypotenuse over adjacent. So it would be the hypotenuse C over the adjacent B. Does that make sense? Okay. The cosecant, which is abbreviated CSC, you can't do COS because that's cosine, right? So the cosecant, okay, well, again, if I do A, sine is opposite over hypotenuse, cosecant is hypotenuse over opposite. So it would be C over A. Okay. Do you have a guess for what cotangent would be? So tangent's opposite over adjacent. So cotangent is adjacent over opposite. So if we're talking about angle A, it would be adjacent B over opposite A. Okay, so those are the other three. There's no great benefit to those because they're just the reciprocals of ones we already have. Okay, so there's no great benefit to them. In a trigonometry class, we study them mathematically, but in a practical sense, you can do the same thing with tangent, sine and cosine instead of, you don't really need those for practical work. Okay. Okay. So find trigonometric ratios on a calculator. Different models of calculators work differently, so you must be familiar with your own calculator. You must make sure your calculator is in degree mode if we're using degrees, okay? So like back here, we found, using this triangle, we found the sine of 36 degrees, okay? I could find the sine of 36 degrees on my calculator, okay? I can find the sine of 54 degrees on my calculator. I can find the cosine of 36 and 54 degrees. I can find the tangent of 36 and 54 degrees on my calculator, okay? So I just want to show you that, okay? So now on my calculator, okay, the first thing I'm going to do is make sure I'm in degree mode. Most of the time, by default, calculators are in radian mode instead of degree mode, okay? Well, we don't want to have to convert to radians to be able to do this, okay? We talked about radians last time, right? So I'm going to go to mode. And if you look here on my calculator, you see right here, I have radian mode and I have degree mode, okay? So you want to make sure you're in degree mode, okay? So if it says radian mode, go over to degree mode and hit enter, and that'll put it in degree mode. Now, again, different calculators work differently. This is how my graphing calculator works, okay? But if you had like a scientific calculator, that works a little differently. You'll have a button that you can use to switch between degrees and radians and gradients, okay? So anyway, just make sure you're in degree mode if you're using degrees in the problem, okay? So once I'm in that mode, okay, if I type sine of 36, I get 0.5877, blah, blah, blah. So that would be about 0.588. You with me? If I do the sine of 54 degrees, that's about 0.809. You with me? If I do the cosine of 36 degrees, that's about 0.809. If I do the cosine of 54 degrees, that's about 0.588. You with me? If I do the tangent of 36 degrees, that's about 0.727. And if I do the tangent of 54 degrees, that's about 1.376. Pretty jiffy, okay? And likewise, the sine of 45 degrees is 0.707. The tangent of 60 degrees is 1.732. The tangent of 45 degrees is 1. The sine of 60 degrees is 0.866. So I could have done all of those with my calculator rather than like drawing out the special triangles. Okay, does that make sense? If I do the sine of 53 degrees, that's this one, that's about 0.8. Okay. Now, again, that's not exactly 0.8, like we got exactly 0.8, but the reason is because that's not really exactly 53 degrees. Okay, so it's approximately 53 degrees. So when I take the sine of 53 degrees, the opposite of the hypotenuse is about 4/5. It's not exactly 4/5. Okay, make sense? Okay. So use your calculator to find each value round to 3 decimal places. So this is pretty easy. The thing that people will do wrong is they won't be in degree mode, okay? And the cosine of 68 radians is a lot different from the cosine of 68 degrees. 68 radians is a lot more than 68 degrees, okay? So anyway, if I do the cosine of 68, that is 0.375 if I round to 3 places. If I do the sine of 72.4 degrees, that is about 0.953. If I do the tangent of 28.75 degrees, that is about 0.549. And then, of course, they hit us with the doozy one. We have to have the sine of 8 degrees and 27 minutes. Okay. Well, 8 degrees and 27 minutes would be 8 plus 27/60 degrees. Remember, 27 minutes times there are in 1 degree, there's 60 minutes. So that would cancel minutes and we'd take 27 divided by 60. So 27 divided by 60 is 0.45. So this would really be 8.45 degrees. So I'm really finding the sine of 8.45 degrees. And so that's about 0.147. Is that hard? And if you wanted, you could have just done sine of 8 plus 27 divided by 60, close the parenthesis, and that would do it. With me? There's also something else on the calculator I didn't show you last time. Okay. Look right here on this calculator, the second of the apps button. You see it says angle? So if I go there, look at what I have. For number 1 there, I have degrees. For number 2 there, I have minutes. Okay. So I could do this. I could do the sine of 8. Whoops. Well, one of these days I'll hit the right button. Degrees. Whoops. Let's try that again. The sine of 8 degrees, 27 minutes. So the calculator will do the work for me if I punch it in that way, which is kind of nice. Any questions about that? Okay. By the way, even if I was in, even if I was in radian mode, if I were to do cosine of 68, well, I keep hitting the wrong button, degrees, then the calculator is going to treat 68 as degrees rather than radians, and it's going to give me the right result. But if I just did the cosine of 68, I get a different answer because that's the cosine of 68 radians rather than 68 degrees. Does that make sense? So if you want to stay in radian mode, you can and put the degree symbol there. That'll do it. Or make sure you're in degree mode. Okay. So I'm going to go back to degree mode. Any questions? So the last thing is this. Okay. In some applications of trigonometry, we need to find the angle associated with an unknown or with a known trigonometric ratio. This is called finding the inverse of the trigonometric function. Okay. Again, you must be familiar with your own calculator to do this. Okay. So if you look at, like I had the sine, the cosine, and the tangent buttons. Okay. So that those buttons are used to find like the sine or the cosine or the tangent of an angle. Okay. If you look at the second of those buttons, you see sine with the little -1 up there. That's called the inverse sine. And if you see the second of the cosine button, that's cosine with the little -1 up there. That's the inverse cosine and the inverse tangent. You with me? So the way that works, I put in the ratio and it will tell me what the angle is. Okay. Now, again, if you're in the radian mode of the calculator, it will tell you the angle in radians. Okay. So if you want the angle in degrees, you got to be in degree mode. You okay with that? Okay. So like, for example, I'll use something we've already done. Okay. So like, we know that the tangent of 36 degrees is equal to 0.727. You with me? So if I knew the 0.727 and I wanted to figure out the 36 degrees, then I would do this. I would do inverse tangent of 0.727, and that'll give me the 36 degrees. Now, it won't be exact because I've rounded, right? Okay. But if I do inverse tangent of 0.727, it gives me 36 degrees, again, approximately because of the rounding. Make sense? Okay. And the same way it works with like cosine and sine. And by the way, like if I do like the inverse tangent of the square root of 3 over 1, that's going to give me the 60 degrees. Okay. If I do the inverse sine of the square root of 3 divided by 2, that gives me the 60 degrees. You with me? Now, when I do the square root of 3 over 2, it gives me exactly 36 degrees, right? If I did inverse sine of 0.866, that's going to give me about 60 degrees because of the rounding. Does that make sense? Isn't that cool? Okay. So find angle A for each of the following. Express the answer both to the nearest tenth of a degree and to the nearest minute. So I'm being mean. You got to do both. Okay. So I know that the cosine of angle A is 0.895. So I want to find what is angle A. So angle A is going to be the inverse cosine of 0.895. So if I do inverse cosine of 0.895, again, I'm in degree mode. So that is about 26.4915, blah, blah, blah. Okay. So to the nearest 10th, that would be about 26.5 degrees. Everybody okay with that? Okay. Now it said I'm also supposed to do it to the nearest minute. So here's to the nearest 10th of a degree. So if I do it to the nearest minute, it's going to be 26 degrees and some odd minutes. You with me? So to change it to minutes, it's the 0.4915702 that I need to change to minutes. Does that make sense? So again, remember, if I have 0.49 degrees and I want to change that to minutes, what I'm really going to do is I know there's 60 minutes over 1 degree. So I'm really going to multiply that by 60. Okay. So what I'm going to do is I'm going to just subtract off the 26 so I don't have to retype all of that. And then times 60. So that's about 29 minutes. So 26 degrees and 29 minutes. Now my warning for you is, had I rounded to the 0.5 minutes or the 0.5 degrees and then change that, if I do 0.5 times 60, that's 30. So I'm off by a minute. You with me? So be careful about that, okay? If the sine of angle A is 0.929, then A is going to be the inverse sine of 0.929. So the inverse sine of 0.929 is about 68.3 degrees. So there it is to the nearest 10th of a degree. If I want to go to the nearest minute, I'm going to subtract off the 68 and then multiply by 60. So that would be about 68 degrees and 17 minutes. And again, if I had rounded and gotten the 0.3 and then times 60, I would get 18 minutes instead of 17 minutes. We good? If the tangent of A is 1.505, then A is going to be the inverse tangent of 1.505. So the inverse tangent of 1.505 is about 56.4. Or that's going to be 56 degrees and some odd minutes. So if I subtract off the 56 and multiply by 60, that's about 24. In this case, had I used the 0.4 times 60, I would have still gotten 24. So it wouldn't have been a problem on that one. But as you've seen, it can be a problem. Is that horrible? So sometimes you're going to know the opposite and the hypotenuse. You're going to know the adjacent and the hypotenuse. You're going to know the opposite and the adjacent, and you can use the appropriate inverse to figure out what the angle is if you need the angle. Okay. So example 7, we'll call it a semester almost, except for the business of a test. Okay. For the triangle shown, find angle A, round to the nearest 10th of a degree. So I want to know what's that angle. Well, how can I do that? Well, it's a right triangle. I know that the opposite's 15, the adjacent's 36, and the hypotenuse is 39. You with me? So I have 3 ways that I could figure out what the angle is, okay? Depends on if you want to use sine, cosine, or tangent, okay? So like, for example, if I use sine, the sine of A would be 15 over 39. Does that make sense? And if that's the case, then that means angle A would be the inverse sine of whatever 15 over 39 is. And I'll figure that out in just a minute, okay? But if you don't like sine, if you prefer cosine, well, you could say the cosine of A would be the adjacent 36 over 39. You with me? And if that's the case, then A would be the inverse cosine of 36 over 39. And if you don't like sine and cosine and you prefer tangent, well, you know the tangent of A would be the opposite, which is 15 over the adjacent, which is 36. So that means angle A would be the inverse tangent of 15 over 36. We okay with that? So if I do the inverse sine of 15 over 39, that is about 22.6. So this would be about 22.6 degrees if I round to the 10th as I was directed. You with me? If I do inverse cosine of 36 over 39, I get the same thing. You with me? And if I do inverse tangent of 15 over 36, I get the same thing. Now, do you have to do it three ways? No, that's silly, right? You wouldn't have to do it three ways, but if you can do it any one of the three ways. Piece of cake. Well, that finishes section 10.2. So you should be able to handle the section 10.2 homework. And should also be able to do the chapter 10 quiz. Okay, so all of that will be due Tuesday by the start of class. Okay, so again, if you are done with your homework and quiz and you don't have any questions about anything regarding chapters 8, 9, or 10, then you don't have to come to class on Tuesday. Okay. If you have questions, bring those questions to class. And again, I'll spend as long as necessary answering those questions. Okay. Any questions about that? Otherwise, if I don't see you on Tuesday, or geez, I keep saying Tuesday, Monday, I'll see you on Wednesday for the test. Okay. Okay. Have a good rest of your day. I'll see you at least next Wednesday.